Okay. Good evening, one and all. So let us brush up last class. So last class we were discussing about distribution of energy between systems in equilibrium. So here we are talking about thermal equilibrium. So there are two systems which are macroscopic in nature with energies E and E dash, and they have got an energy. Fine. So we were here. So what happened was the energy range I took it as delta E and delta E dash, such that omega E and omega dash E dash are the accessible states, and they have got a spread out energy of E plus delta E and E dash plus delta E dash, where E is the E and E dash are the ground energies of both the systems. Okay. So ground state, if you add both the system energies, you will get a constant value. So that I am calling it as E0. Fine. So with that now, I went to the calculation of the total probability of the whole system. So whole system means what A it is, system A. System A is made up of two systems. So just now I was telling that. So one is A, another is A dash. Okay. So let omega 0 E be the total accessible state present for the entire system. Then probability of finding the system in these accessible states is proportional to, what is that? Omega 0 E. So if you remove the proportionality, you will get a constant. So you will get C omega 0 E. So omega 0 E is the total accessible state for the entire system. Okay. So this we have discussed in the last class. Okay. So with that now, omega 0 E I wrote as a product of two accessible states, because the whole system is made up of two states. So one is system A, another is system A dash, isn't it? So naturally, omega 0, it can be written as omega E times omega dash E dash. Okay. But E dash just now have shown you in the previous slide. It is made up of, E0 is made up of E plus E dash. So E dash can be written as E0 minus E. Okay. So if you use that, the value of omega 0 E comes out to be omega E, omega dash E0 minus E. This is the total number of accessible states. So if you substitute value of omega 0 E in the previous equation, so what was the previous equation? This one, C of E equal to C times omega 0 E. So if you substitute in that, you will get P of E is equal to C times omega of E, omega dash E0 minus E here. Okay. So both A and A dash systems are having many number of degrees of freedom, and omega E and omega dash both are rapidly changing functions, because energy is changing, omega value is changing. It is not constant, rapidly varying the values they have got. Okay. So now here I will be putting one condition. So what is the condition? As E increases, what is E? E is the total energy of the system. Okay. So if that increases, omega increases, while omega dash decreases. If total energy is increasing, so what should happen? One value of omega should increase, one should decrease, so that the total value should remain. I will come back to this slide. So here you can see E is the energy of the first system, E dash is the energy of the second system. Okay. So if E is increasing, what should happen? E dash should decrease, such that E0 should remain constant. So that's what it is written here. So as E increases, what is happening? Omega is increasing. That is, first system is active, whereas second system is not that active. So what happens? E dash decreases, omega dash decreases. Okay. So here one small condition I have put, that is maxima will occur at one point. So if it has to occur at one point, that point I will be calling it as the average energy, E bar. So what is the condition for E bar? E bar should be very, very large compared to the line width of this plot. So what is that? So if you come to the second slide, next slide, so you can see here my whole system is A0. It is made up of A and A dash, two values. The total accessible states are omega zeros. Individual accessible values are omega E and omega dash E, omega dash E dash. Okay. So here you see there are two parts. So in one part, A is dominating. Let us say left side A is dominating. A dash is dominate on the right side. Okay. So when A increases and reaches the maximum value, what happens? Then it starts losing energy. So this portion will start. So both of them, they will be having maximum energy at one point. So that point, I am calling it as E bar. So what is E bar? It is the average energy of the system. So what is delta star E? If you take the peak of this graph divided by root 2, okay, you will be getting some value. So that value locate on the y-axis and draw a line here. It cuts at 2 points. So then draw two vertical lines. So they will be intersecting x-axis at 2 points. Now you measure the width of this rectangle. So this is one line, second is this line. So middle one is the average value. So you measure this width. So that width I am calling it as delta star E. So here what is the condition? Delta star E should be much less than E bar. So at only one point it is shooting up. If you go to left side also it falls. If you come towards right also it falls. So what does it mean? It means that you are representing probability as a delta function. So I think in the class it might have been taught the characteristic of delta function. So delta function is a function. It will have two values. One is 1, another is 0. So this point, the peak refers to 1 and the other points refers to 0 values. That is on and off. So on means 1, off means 0. So that means probability is represented as delta function. You can see here it shoots up at one point. So this is on position. The other two are the off position. So probability is represented as delta function. So now with that, I am going to the next slide. So here I am defining the total energy divided by F. So what is F? It is the degree of freedom of the system. I mean, I am talking about the whole system. So what is whole system? Whole system is A0. So A0 has got a degree of freedom as F. So now if you divide it, E divided by F, you will be getting epsilon. So what is epsilon? It is the energy per unit freedom. Okay. So if you define that, then using that you can define omega E. So what is omega E? It is accessible state for which system? System number 1, that is A. System A you are defining. So system A have got omega E as the number of accessible states. It is proportional to epsilon to the power F. Okay. So now similarly, you can write for another, sorry, this is E, not epsilon, E is capital E. So because it is dependent upon E, you can also write it as epsilon also. That's also possible. E to the power F it is. Fine. Just a minute. Okay, e to the power F. So similarly, omega dash E dash, you can write it as e to the power F dash, proportional to that. So now you take these two values into the definition of the probability. So where is the definition of the probability? So I wrote in the earlier slide, that is total probability is the product of omega E and omega dash E dash. I wrote it in the 2 slides back. So I'm using that equation now. So I'm writing the value of total probability as proportional to the product of omega E, omega dash E dash. So now you remove the proportionality, you will get a constant here. C is the constant. So now in terms of energy also you can write. So if you write in terms of energy, omega is proportional to e to the power F. So P is proportional to e to the power f, okay, and into e dash f dash. So in that way also you can write. Fine. Just a minute. So in this one, if you have got any doubts, you can ask me. So I have defined two energies. One is the energy per unit degree of freedom. So if you are writing for system A, it will be E by F. Okay. So if you are writing it for A dash, it will be E dash by F. Okay. So what energy values you are using, you take care of that into that equation. So omega E, it is also written in terms of epsilon to the power f here. So actually here, okay, I wrote that epsilon here. I have written as phi. Both are same thing. But phi is some function. It is dependent upon epsilon. What is epsilon? It is energy per unit degree of freedom. It is function of that, or simply it is function of energy, total E, E or E dash, whatever it is. You can put energy value here. So accessible state, it is given by phi of epsilon to the power f. So for the special case I have shown here. So f, if it is 1, it will take 1 value. If it is 2, it will take 2 values. 3 values, 4 values, etc. 1 means ground state. 2 means there are 2 excited states. Of course, one is ground, another is the excited state. 3 means 1 ground and 2 excited states, etc. It will continue. So for a given system, I have taken f values. If phi is 10, f will take the value 1, 2, 3, 4, etc. Okay. So that is meaning of that. So now with this now, I'm moving from this equation. So remove the proportionality, you will get a constant here. So if you take out the write the constant here. So what you will get, P is equal to C into e to the power f, e dash to the power f dash here. Okay. So what is the connection between e dash and e, whatever it is? E0 is equal to ef e to the power f. F means it refers to degree of freedom. So E dash to the power F dash. Okay. So if you take ln of P, so this equation, above equation, it turns out to be F of ln of E, F dash of ln of E dash plus T. So I'm calling that equation as equation number 1. So I'm using that equation of 1. So now I will be moving to the next slide. So I am making use of this equation. These are the basic equations I am going to use. So now I have to locate the maxima. So to get the maxima, first what we should do, we should take ln of P. Okay. So ln of P is ln of omega dash plus ln of P. So I am calling this as equation number 1. Okay. So what is the condition for maxima? Differential of ln of P with respect to energy should be 0. Why it should be 0? It is a delta function. Only at one point it has got a maxima. That is the shooting point. That is. So just now I have shown you the graph. So to get that, what I should do? I should make this differential of ln P with respect to E. That should be equal to 0. Okay. So why it has been made 0? So actually this taking differentiation means what? You are taking the slope. Slope on the left side, slope on the right side. So it is 0. 0 means what? So there is no points at all, neither on the left side nor on the right side. Only at one point you have got a value. That is at the maxima. That is meaning of that. Okay, that's how maxima is defined. So that is why this is nothing but it is represented, P or ln P is represented as delta function. Okay. So now you take the differentiation, ln P is 1 by P, dou of dou E of P. So right hand side it is 0. So where maxima is occurring? Maxima is occurring at E bar. Okay. So now I am taking equation 1 and equation 2 together and ln P I am substituting from equation 1. So and then I am applying differentiation. So if you apply differentiation, you can see there are three parts in equation 1. So first the differentiation will go with ln of omega, and second differentiation will go with ln of omega dash. Okay, that is the second term. But here I have written it as E dash. First term I have written it E. Why? Because omega dash depends upon E dash. So if I take with respect to E, the value becomes 0. I don't want that. So what I will do? I will differentiate second term first with respect to E dash. Then I will multiply it by another differential coefficient dou E dash divided by dou E. And anyhow, dou E dash and dou E dash will get cancelled. So what is left out? Dou of ln of omega dash divided by dou E. So nothing has changed. It remains same. So plus. So what is third one? ln(c). ln(c) differential with respect to E, I have put it right hand side, I have put equal to 0. So now you see C is a constant. ln(c) is a constant. Fine. So if you take the differentiation of that, it will become 0. That means the third term is 0. So now only two terms are left here. So one is the first term, another is the second term. Fine. So now I am copying as it is first term. Second term also I am copying. But here I am making the correction here. So what is the correction? Total energy, if it is E0, so E dash is written as E0 minus E. Okay. So what I want here in the upper equation, I want dou E dash divided by dou E. So take differential of this equation with respect to E. So if you take differentiation with respect to E, what happens? First term is a constant. Its differentiation is 0. Okay. Only the second term, I can differentiate it. Okay. That is dou E by dou E with minus sign. So anyhow, dou E by dou E is 1. So that's why I'm getting here minus 1. So that minus 1 I have introduced here in the second term. So now how many terms are left out? There are two terms. One is ln of omega. Of that, I am taking differentiation with respect to E minus differentiation of ln of omega dash with respect to E dash it is. And right hand side it is 0. I have copied 0 as it is. Okay. So now what I will do? I will push the second term on the right hand side. Okay. And I am calling left hand side as beta of E. Right hand side I am calling it as beta dash of E dash. Okay. So we have arrived at one of the important steps in the derivation. So for 2 minutes, I'll give you a break. So just go through this slide. If you don't have not understood anything, you ask me. Otherwise, I will continue. Any doubt is there?
No, ma'am.
No. Okay. You have understood. Fine. Next, I'll go to the next slide. So here I have written in a comprehended form. First term is written as beta E, and second term it is written as beta dash E dash. So E is not necessary to write, it is understood. So beta depends upon energy. What is beta? It is 1 by kT. Okay, it comes from an equipartition energy theorem. So I understood this in BSc. Okay, beta is 1 by kT. So from that I am doing. So I'm moving to the next slide. So what is kT? kT is 1 by beta, or beta is 1 by kT. Okay. And what is the connection here with respect to omega, K and S? S is the entropy, K is the Boltzmann constant, and omega is what? Accessible state. Okay. Accessible state. Just now we have studied that. Okay. So now you go try to remember the equation. CE is equal to C times omega E omega dash E dash. Earlier I wrote that. Okay. So now ln P of E I have to make maxima. Okay. So ln P of E, if you make maxima, what you will get here? ln C, ln of omega dash. So no need to write E if you want to make it short form. Okay. So now you see here, left hand side anyhow, ln of P of E, keep it as it is. Don't worry about that. After equality, first term I have written here ln C. So what is ln of omega e? It is nothing but s by k. You see for s equal to k, from that omega is s. So similarly, ln omega dash, what is that? S dash divided by k is equal to maximum. So now you take ln c on right hand side. Maximum means constant it is. What is on left side? S plus s dash, k is common factor. So I have written common divided by k. So k you take on the right hand side. Anyhow, all the terms on the right hand side are constant. Multiply it by k. So again you are multiplying. So that means the maxima will remain maxima only. Okay, if you divide it, reduce, you are multiplying. Okay, so that's why. So the equation turns out to be s plus s dash is equal to maxima. So this is one of the important equations under the probability calculations of the joint system. Okay, so with us now, I'm moving to the next slide. Is there any doubt in this slide? Hello? So I'm going to the
No,
next
ma'am.
slide. Okay, just a minute. I will go to the next slide. Okay, this slide is completed. So now I'm going to the next slide. So in this slide, what I have written? I have written omega as what? Product of another omega. You see there are two omegas. Left hand side is the capital omega. Right hand side is the small omega. Similar to capital letters and small letters. Okay. So capital omega is equal to small times omega times delta E. So what is delta E?